Hello, my name's Alex Ward, and welcome to From Chaos to Control Capacity Planning in Microsoft Fabric. Now, this presentation came from a place of pain, a place of frustration. I've been learning a lot about capacities in Microsoft Fabric due to numerous issues, and I'm hoping that I can pass on what I've learned to you so you haven't got to make the same mistakes. Right, so let's get into it. Okay, so Microsoft Fabric. Microsoft Fabric is split into two sections for ease of billing, and that is compute, which your capacities are going to be looking after. And that includes all of your Microsoft Fabric workflows, so Data Factory, analytics, databases, Copilot's in there as well. And then storage of OneLake is split off, so you'll see that in a different bill. Next, we have the F SKUs for capacity, starting at F2 and up to 128 there. So you can see that F2 means you've got two capacity units. It's a pay-as-you-go pricing, so you can resize those SKUs as required. It also gives you the ability to pause and resume. So if you're not using it, you should pause that capacity. Once you're comfortable with what capacity you're using, you can go to a reserved pricing structure, which will save you 40%. But you need to ensure that your usage is fully understood before you commit to that. Two capacity units will equal one vCore, so a standard warehouse. One of the biggest things that we'll need to learn about capacity usage is bursting and smoothing. So bursting enables temporary access to additional CUs. So it will accelerate your workload execution. It'll just give you access to all of your future capacity for any item that you're running at the time. So we've got an example scenario. If a job runs on 64 CUs for 60 seconds, with bursting, it can run on 256 and finish in 15 seconds. So it's really useful for time sensitive and performance critical tasks, and provides flexibility and scalability without constant resizing. Or that's the goal anyway, but this is quite difficult to manage. The bursting's not unlimited, so for an F8, between F8 and F2048, it'll give you times 12 capacity units. In the earlier stages, I think an F2 is 36, an F4 is 28, I believe. But yeah, so it's not unlimited. And it'll just give you that quick burst that you need, but it is borrowed, so we'll have to pay that back over the day. And that's where smoothing comes in. So smoothing is where we grab bursting and say, who's been a good boy, and we calm it down for the rest of the day. The purpose of smoothing is to prevent users from being penalized for that short-term use, and we'll borrow from the bursting and then gradually smooth throughout the day. So it ensures that we're consistently fast without throttling. So smoothing works by averaging that CU over a longer time frame. So giving you a quick grab, but then borrowing from your future capacity. It distributes the consumption across future time points. And each time point in Fabric is 30 seconds long. There are 2,880 time points in a 24-hour period, and Fabric will automatically manage that CU across these time points. For interactive operations, we've got 5 to 64 minutes smoothing. Now that's from Microsoft Learn. I believe that's correct. It's a strange number, so I've left it in. For the purpose of this presentation, I'm going to round that off to 60 later. So yeah, 5 to 64 minutes of smoothing. And what are the interactive operations? So we've got in Power BI, we've got when you're viewing a page, when you're rendering, any direct query, interactive queries for the semantic model, web modeling, and user data functions. Quite surprisingly, KQL is interactive. So anything that we're doing with event streams will be interactive. The Fabric API and database SQL queries. Background operations. These are smoothed over 24 hours. And again, Power BI comes into that, but that's our scheduled refresh, report subscription, interactive queries, and other workflows that you can see there. So the smoothing benefits. It reduces the CU impact on any single time point, and it minimises our risk of throttling. It allows for our operations to run concurrently without causing those performance spikes, and it enables better job scheduling and resource utilisation. Users will experience faster performance without needing to micromanage job timing. That's the goal. It doesn't work that way. We need to be paying particular attention to bursting and smoothing if we're going to run these capacities correctly. So here is a visualization of what we'll see with bursting and smoothing, and I'll slow this down over the next couple of slides, but I just wanted this to run because it's a good visualization of what is happening throughout the day. So regardless of skew, Fabric bursting will automatically allocate resources as you need, and as such, one query could consume the whole quota for the day and leave you in a bit of a bind. So to avoid an overload, smoothing kicks in. Now here's where we're spreading it through the day. So no one query can trigger an overload. Instead of allowing those queries to create a local overload, Fabric will smooth that out throughout future time windows in a buy now, pay later installment plan. And here we can see another batch job has started, and it's on top of the smoothing that we're experiencing throughout the day. So at this point, we've got it was traditionally a threat to interactive queries because we've got this big job which may stop users from seeing the reports. Traditionally, we had to carefully schedule these jobs to off hours to avoid interference. Now we've got a similar installment plan for the batch jobs, but the batch jobs are being smoothed over 24 hours. So this, I've left this sentence in, this completely liberates the DBA from any considerations of job scheduling. That's a ridiculous statement. We will need to schedule these jobs accordingly if we're going to handle bursting and smoothing effectively. So regardless of when batch jobs are scheduled, there will not be any degradation on interactive query performance. It's not fully accurate. That's the goal again. Even after smoothing, there's times when the jobs are going to build up and cause a capacity limit. So we can see here 7, 8 and 9, they're over our capacity. And what happens here is we carry those forward. So it's above the usage limits, and we're going to give ourselves some available capacity and carry those forward here. Now, carrying usage above limits into future periods, it further lessens the spikes, but when thinking about the capacity load, we want to think about the percentage consumed and the amount of future periods filled. So have we got enough capacity throughout the day to pay that back? So here's an example of smoothing. We've got a background job that uses 1 CU per hour, so that's equal to 3,600 CU per second. Fabric's going to spread those evenly over 24 hours, and remember we've got 2,880 time points, each 30 seconds long. So each time point's going to get 1.25 CUs per second. We've got 3,600 divided by 2,880. F2 will give us 2 CUs per second. So that's 60 CUs per 30 second time point. So the job shared per time point is 1.25 divided by 60, and that gives us around 2.1%. So what's the throttling impact of that? If that's a 10-minute window, we've got 1,200 CUs per second available. So that job contributes 25 CUs per second in that time. 1.25 times 20 time points. So the impact of that is 25 divided by 1,200, which is around 2.1%. If that's a 60-minute window, we've got 7,200 CUs available. The job contributes 150 CUs per second, so 1.25 times 120 time points. And throttling impact for that is 150 divided by 7,200, so again it's 2.1%. It's a lot of numbers, but it gives you a kind of good example of what's happening here. And here we get throttling, right? So throttling happens when there's no future capacity to pay back the overusage, or as we call them, overage in Fabric. It applies at the capacity level, not the entire tenant. And here with throttling, we can delay or reject operations depending on usage. It's because of a build-up of background activities and heavy interactive queries. We've got long-running semantic models could cause the issue, longer than usual running ETL jobs. So if you've got more data than you expected coming in, that could cause throttling. Rerunning jobs or refreshes, and the number of operations might not be fit for that capacity. So what are the stages of throttling? We have got, we get some alerts that'll come through. This is how you're going to see throttling. You'll start to see status codes of capacity limit exceeded. In your notebooks, you'll see that your organization's compute capacity has exceeded its limits, and it probably won't let you run the notebook. Semantic models can't load, and it'll say it's due to reaching the capacity limits. So the stages that we get, if it's under 10 minutes, if it's going to take us under 10 minutes to pay back that overage, we don't get throttling. If it's between 10 and 60 minutes, we start to get interactive delay. So your users will see a 20-second delay of them opening a report. If it's between 60 minutes and 24 hours, we get interactive rejection. So new interactive jobs are rejected. So people can't start, they won't be able to see the reports. And if it's over 24 hours, the background jobs will start to get rejected. So you'll have your currently running background jobs, so your pipelines will still be running, but all new requests, anything that's scheduled, will start to get rejected. So at this point, we need to start getting our detective hats on and figuring out what has happened. And we've got 3 products that we can use to figure this out. We've got the monitoring tab that's built into Fabric. We've got the capacity metrics app, which will tell us what's happening in particular across the capacities. And then we've got the chargeback app, that we'll use to find out who has caused the issue. So the monitoring tab is, as I said, built in, and here we're going to see what's running right now. So we can identify the impact of the current outage. So which operations need to continue, who and what's going to be impacted, and can we cancel anything to free up some capacity. We can identify the failed operations, so which operations are going to need to be restarted once we've solved the issue. The limitations of this is that it doesn't show the interactive activities, and it only shows operations that you specifically have got access to, and it lacks detailed analysis. The Fabric Capacity Metrics app is going to be your bread and butter for managing capacities. It'll give you detailed point-in-time analysis of throttling and rejection. It'll allow you to identify which operations get throttled or rejected, and which operations are causing the capacity issues. So, and we can also monitor the problematic operations from this app. And here's the layout. We've got one will show us the CU consumption by operation type, and then 2 will give us an overview of the capacity usage, and 3 will give you the item list. Now we can drill into these So what I'd recommend is that in number one, you drill down to the day that you want to look at, and then further into the hour, and then move over to number two, where you can pick a 30-second time point. And here's what you'll see with the time point detail. You've got your base capacity over here. We've got the 9.4 for the interactive operations, and then you've got the background operations of 92.40, which equal over 100%. So then you'll see your overages below. So this is what you're going to pay back in capacity. If the overages can't be resolved in 10 minutes, remember, that's when throttling occurs. So we can't forget smoothing here. So we want to grab him and say, who's a good boy? But he's not a good boy. Bursting and smoothing have gone crazy. They've weed on the floor, and we've got to deal with that throughout the day. So here you can see a couple of items where we're looking at this from the 2nd of October, but we can still see items from the 1st of October. So that's how much smoothing can impact us throughout the day. And remember, these activities get stacked on top of each other. So we need to be paying attention to all of our overages and every item that's still smoothing throughout the day. And we can see the item performance. So specifically, we want to look out for the items that are using the majority of the capacity units. And then we want to look at anything that's highlighted, because the colours will indicate the performance of that item. So it won't give you full details of what you need to do, but you will need to optimize that process. And lastly, we've got the chargeback app. So I said this is where we can find out who or what is causing the issue. So the visuals that we've got on offer here, we've got we can split down to workspace, item, domain, and subdomain. So we can show the percentage of the capacity used, and the utilization of the CU by date, and we can get into the CU details as well. So we've got a matrix table where we can it's got a user level breakdown, and then we can drill through. As with the capacity metrics app, we can drill through, just go back, I skipped too early. We can drill through into the workspace details, item details, and domain and subdomain. And we can also export this data if we need. Now I've put this in as an honourable mention. It's FUAM. It's more than an honourable mention. This is a great report which will give you a lot of detail when it comes to the specifics of the item. So here you can use this product to start future planning and optimizing any item that's causing you particular capacity issues. Now I've put it in as an honourable mention because I haven't used it in depth, so I won't be able to give too much detail about FUAM. I've installed it. It's available on GitHub, and the installation doesn't take too long. It's a bit more complex than the others, but it does give you a lot of detail. It was just too much detail for me, for my uses, and I was quite happy with the capacity metrics and the chargeback app. So yeah, FUAM, give it a go. It's free on GitHub, and you'll be able to install that quite easy. So what tasks should I specifically look at? So Dataflow Gen 2 will cause quite a spike in capacity. If you're relying on it too much, it will cause the capacity usage to spike. Microsoft are introducing parallelization, which will improve the capacity usage of the Dataflow Gen 2. So if you've come from a BI background, or you're just comfortable with Power Query, you will start getting optimized Dataflow Gen 2, but we're not there quite yet. So watch out for them. Inefficient semantic model refreshes. So if you've got a lot of calculated columns, or you're pivoting, merging, that could cause you quite an issue. If you've got paginated reports, try and move away from those. Complex user queries, inefficient DAX, and so on, and Copilot. So what can you do? You can move your workload to cheaper options. So Dataflow Gen 2, obviously it's very user friendly, it's very visually appealing, but if we can get users to start using notebooks, we can do a lot more transformation, easier with PySpark, but it's getting people used to that. So what I'd recommend is that you start building templates for your notebooks, making it quite easy for people to start using Python, and just give lessons on how to use that. Semantic model operations. So we want to transform. We want all of our transformations to happen in the warehouse or lakehouse, and then use direct lake to optimize our models. The paginated reports, try and get people to move to Power BI dashboards. It's a hard ask for a lot of people, but that's where you're going to feel optimization. DAX optimization, we actually have the best practice analyzer built in to the web experience now. So try using that, try optimizing your DAX. And with Copilot, we can leverage Copilot capacities. So if your organization uses Copilot quite heavily, put it into its own capacity where you can view the charges for that specifically, and it won't affect anything else that you're doing. So on to specific optimizations that we can do. So with the warehouse, we can, so warehouse is it's serverless architecture. The compute is managed automatically and usage is measured by active per query capacity units per second. The background operations, all of the workloads are going to be smoothed over 24 hours. And it's a performance-focused SQL endpoint. So it's got limited query tuning options compared to traditional SQL platforms. The efficiency tips, we want to use optimal T-SQL. So limit the columns that you're bringing in, the calculations, the joins. Choose minimal data types. So if you've got a varchar field, limit the length from 500 to 25. Apply the star schema design for better performance. And maintain and update statistics, preferably with full scan for accurate execution plans. Monitoring tools, use the sys.dm_exec_requests for live query tracking, and use queryinsights.exec_requests_history for historical query analysis. We can optimize our notebooks by writing efficient Spark code. Reserve only required executors, so to prevent resource contention and errors. Stop inactive Spark sessions. So these can often run for, the default timeout is 20 minutes. A little tip is to add this into a separate cell at the end of all your notebooks, and that will force it to stop once it's run all of the activities. Use the burst factor to your advantage. So allow parallel Spark jobs within SKU limits, and monitor the usage. Always monitoring the capacity usage here. So we can monitor that via the monitoring hub, track the executor allocation and job performance. Optimize data factory. So we want to minimize the compute usage by avoiding inefficient Power Query logic. So merging, sorting. Enable query folding to push the transformations to the source system. Disabling staging will help. Disable those for your small and simple workloads unless necessary. And refresh your data only when you need it. And Power BI, we need to manage our interactive operations. Get away from the poor semantic model design. So use your star schema. Try and avoid any complexities there. Optimize your DAX measures. Overloaded report pages, stick to 6 to 8 visuals. Don't just have loads there because it will take capacity. On high concurrency, so if we've got a lot of users, consider enabling query scale out. So this is going to improve the experience, but not the total compute. Your background operations, so any complex Power Query transformations, as we've mentioned, try and minimize those. Enable the query folding, incremental refreshes as well for larger tables, and report bursting. So be careful we're not generating too many BI reports or paginated reports at the same time. And how do we stop throttling? So throttling is going to happen, and we need to be able to react to it. Now, the capacities will recover over the 24 hours, but you may have to wait. So it's always going to be best to wait. That's going to be the best thing to do, but obviously that's not going to be an option for a lot of issues. So we can wait until the overload state ends before submitting any new requests. And we can perform CPR, so capacity pause resume. But you need to be careful with this because it does trigger a billing event. So nothing's for free. So we are going to have to pay back this capacity, and we either do it through smoothing or we pay a fee. So that'll be it could give you a nasty surprise in your Azure bill. When it's resumed from a pause, your capacity does start with 0 future usage, but that's because we've paid for it. We can temporarily increase the skew. So just set it to a higher skew. It is pay as you go, so we'll get those processes through and then reduce again. It accelerates the carry forward burn down and it reduces the throttling duration. Switch the capacity. So as long as you've got another capacity that you're able to get your workspaces across to, remember you can't do it by item, it has to be workspaces. We can move it to another capacity, but the capacities must be in the same region as the workspaces. Prevention is going to be key here. So we need to set notifications in the admin portal. Always monitor the capacity metrics app. Just make it something that you do first thing in the morning or at any point in the afternoon. You have to be constantly monitoring this. Enable surge protection. So we can reject new background operations to keep the capacity for the interactive operations. Set yourself a rejection threshold and a recovery threshold, and this will protect those interactive processes. We can also use auto scaling for Spark jobs. So you can move all of your Spark jobs out of your capacity and just pay as you go for the consumption. It's ideal to keep the lower capacities performing, and it's a setting on the capacity level. Also, like we mentioned, we can set up a Copilot capacity. You want to plan your deployment before you start getting into one large capacity and then reserving it for 40% saving. We need to plan accordingly. Microsoft will give you that Fabric trial capacity, which is an F64. It's very, very comfortable to use, but you can watch your capacity usage in the metrics app, so you can be confident of the capacity that you need before making a move on this. Make sure you make the most out of that trial so that you can really understand what capacity you need. So when we're first starting and we're building out a proof of concept, keep the scope narrow. Create one pipeline into one lakehouse and one BI report, and make sure that you're monitoring it through. Use a dedicated workspace. So isolate the proof of concept from anything that you've got in production. Review the trial limitations. There are limitations when it comes to region and AI selection and AI Copilot inclusion. And monitor your usage and gather feedback from the users as well. So you can monitor it in the capacity metrics app, but also involve end users. Moving from development to pilot, we can estimate and acquire capacity using learnings from our initial proof of concept phase. Develop on a non-production capacity, so allow flexibility and stress testing without affecting any of the users. Run a controlled pilot with a larger user group, and where we're going to be monitoring the usage and performance as we go. And we want to optimize consistently. So optimize the solution during the pilot by tuning the queries, everything that we've mentioned previously. you need to get that involved. And this allows us to forecast our production needs based on the metrics that we've seen here, ensuring that we choose this SKU that can handle everything comfortably. Now we want to move to production, so we can scale up to production capacity, and this will support full user loads. And we need to monitor continuously using the capacity metrics app, set the alerts for the usage threshold, leverage auto management features like bursting and smoothing. As long as you're on top of them, you can navigate them effectively. Optimize continuously. Always optimize. Get yourself a center of excellence and improve the performance together to reduce the costs. Plan for scale up or scale out. So depending on the growth, the scale out offers the better isolation for workloads, but we want to be scaling up if we need to as well. And implement governance. So assign monitoring responsibilities, use the surge protection, and report on capacity usage regularly. Communication is so important here because we want to make sure that we're all aware that everything we do has an effect on the capacity, and we don't want one person taking all the sweets. So we want daily stand-ups, keep your devs in line, make sure that everyone understands what's going on, understand what work's happening and when it's happening, ensure that everyone understands the capacity issues and collaborate. And isolate workflows. So completely isolate heavy data ingestion from business intelligence, because you don't want your users affected by a problem that you're having behind the scenes. So this is my optimal capacity model. I've put a little star there because it's probably not going to work for everyone, but this is what suits me. So I have and before I go into it, make sure if you're not the person that is managing the capacities directly, but you are responsible for the bill, make sure you set your quotas in Azure so that the team can't use more SKU than you can afford. So our first capacity is where we're going to be initially testing things. So this is where we're going to build our proof of concept and anything else that's going to come into production. We want to isolate it first in our test capacity. And this can be on pause if it's not being used, and that's going to save you money there. From there, once we're confident, we're going to move it into a dev and test capacity. So here, obviously, we're going to be adding development items, and we're going to allow our users to test in this capacity as well. If this does have throttling, then it's not going to impact anything else going forward. Once we are confident that we've got everything in place, we then move to a production capacity, which has a larger SKU and gives everyone the ability to work comfortably. Here we're isolating any business intelligence. So important reports for users, they need to be completely isolated from any ingestion, any heavy tasks that are happening. Then we've got two more options down here. So if a very intense job's happening in production and it's about to cause throttling, we can move that workspace into a recovery capacity. So we can split it off from the rest of production so that we can allow for that bursting to happen and allow for that job to complete comfortably before moving the workspace back to prod. And we also have a quarantine capacity, which again can be paused when we're not using it. But this is for it's a reduced capacity. You might want to remove bursting and smoothing completely from this capacity, and this is where we want to put any workflows that are not being optimized by your devs. If it keeps on giving us issues and no one seems to be respecting the work that you're putting in, move them into quarantine, and at this point they will struggle with slow data ingestion, but the jobs will get done, but they'll really feel the need to optimize. So there's an option there for your quarantine capacity. And that is it. So thank you very much for watching. I hope this has been beneficial. Obviously, like, subscribe, comment if you feel like I've missed anything out, or if you've got any different opinion on how to manage capacities. And then add me on LinkedIn. So my name's Alex Ward, and I'll constantly be posting things about fabric. So that should be useful. Be great to connect. All right. Thank you. Bye.